That's all right. Continue to write while I'm talking. You got this written down, Tahi?
Yeah, I got it.
Are you talking?
Tahi is Tahi.
Tahi's got it. He's getting it done. So we've introduced this equation already, right? Y is equal to kx. Okay, this is exactly what we did in our warm-up, so it's going to look very, very familiar. What we're going to tackle today is figuring out what makes an equation proportional versus not proportional. It's a very, very simple thing to identify. When we talked about our graphs yesterday, right? What made those graphs proportional? There was two things we were looking for. Tariq, what was one of them?
One of them, if it went through the origin.
If it went through the origin, that was one of them. What was the other thing it had to be? A straight line, right? So there was two things. We use our eyes. We can clearly tell, oh, this is proportional because it goes through the origin and it's a nice straight line. Today we're not going to be looking at graphs. We're going to be looking at equations like this. All right? So let's break up the parts of this equation. We already know what k is. K is our constant of proportionality. Much easier to just call it k. Like we saw in our warm-up, 4 quarters per dollar. That was our k value. And x and y represent something as well. X is going to be our independent variable.
Wait, do you have lead?
I have a pencil. You need a pencil? So like I was saying, x is going to be our independent variable. Y is going to be, what's the opposite of independent? Dependent variable.
Who said that?
And when I was a student, I always got confused about which one was which. The easiest way to remember it is kind of like what we talked about yesterday with y, or the other day with why aren't you over your x? If you're independent, you don't need your x anymore, right? If you got an x, you're single, independent. So when you think of x, think independent. Does that kind of make sense? That's just the way I remember it. I don't know if that helps you. It helps me. So if you got an x, you're independent, right? So if x is independent, obviously y must be dependent. I don't have a easy way to remember that, but if we remember x is independent, then we know y is dependent. And basically what this means is that whatever our y is equal to, it depends on what our x is equal to. This is going to be kind of a hard concept for us to grasp. So let's think back to our warm-up, right? We had y equals 4x, where x was the number of, was x the number of dollars or the number of quarters?
Quarters, right?
It was the number of quarters, right? No. X was the number of dollars.
Oh yeah, it was.
Yeah. Sorry. X was the number of dollars. Y was the number of quarters. Right? Like we said, $1 is 4 quarters. $2 times 4 is 8 quarters, right? So the number of quarters that you have depends on the number of dollars you have, right? The more dollars you have, the more quarters you have. Okay? It's a little bit tricky for us to kind of grasp that, so we'll go into more detail a little bit later. We're going to keep it nice and simple today. So this is a proportional relationship, right? There's always going to be 4 quarters in $1. But we can also have a non-proportional relationship. And a non-proportional equation is going to look like this. Take a moment, get that copied down. I know it's hard to think and write at the same time, so we'll write first, think later. What do you guys notice about this equation that's different than the other one?
There's another.
There's another variable. What is the variable, Tariq? B. We got a B hanging off on the end. And a B is our initial value. I'm going to drop this down. Hopefully we've got that first part. B is our initial value. Again, we're not going to go into too much detail right now. We've got plenty of time. But just know, when you've got another number hanging off on your equation, whether you're adding it or subtracting it, that makes my equation not proportional. Okay? That's basically all we need to know. For example, if I have the equation y is equal to 1/2 x. Okay? Is everyone good if I move the notes down like that? Okay. Am I going too fast? No? Okay. So if I've got the equation y is equal to 1/2 x, show me with your thumbs. Give me a thumbs up if you think this would be proportional. Give me a thumbs down if you think this would be non-proportional. Based on the two equations we just saw, do you think it's going to be proportional like this or non-proportional like that? What do you think? Okay, I see some thumbs down. Just take a guess if you don't know. Okay. Ooh, I see a healthy mix of up and down. Let me ask you, I know, I'll move it down. Okay, if I've got this, right? What number's in front of my x? K. And what is that here? 1/2. Is there a number hanging off on the end of my equation? No, I don't see one at all. So that makes this proportional. Our thumb should have been up there. This is proportional. That's okay. The first one's always the trickiest. This is proportional. Y equals kx. I don't see a b there at all. Okay? Now, if our equation is proportional, that means we can find what k is. And it's not hard to figure it out. It's the only number that we see. Right? So here, what did we say k was equal to again? 1/2. It's the only number that I see. Okay? Let me show you kind of a contrast here. If I have y is equal to 1/2 x minus 2. All right, go ahead and write that equation out. Y is equal to 1/2 x minus 2. What do you guys think for this one? Thumbs up if you think it's proportional. Thumbs down if it is non-proportional. Good. I see a whole lot of thumbs down now. That's exactly right. What makes this non-proportional? How can you tell just by looking at it that it's non-proportional? Vincent? The 2 at the end, right? This formula follows this pattern. Y equals kx plus, in this case minus, but it doesn't matter, that extra number on the end. That makes it non-proportional. When it's non-proportional, there is no k value. Even though 1/2 is in front of my x, this is not proportional. So 1/2 cannot be my constant of proportionality. I know that's a lot of big words and it can be confusing. If you see that extra number on the end, right away it's not proportional. In the same way that yesterday, if you saw that line not going through the origin, it is not proportional. Let me see if we can figure this one out. Our third equation, y equals x. What do you guys think for that one? Thumbs up, proportional. Thumbs down, non-proportional. Good. Ooh, interesting. I see some more differing opinions. This is going to be thumbs up. This is proportional. Okay? This is proportional. Is there a number in front of my x? Do you see one? No, right? But there's something there. What's my invisible number that's really in front of this x? You guys remember? A 1, right? There's an invisible 1 in front of that x. Is there a number hanging off the end? No. So that makes it proportional. That's the only difference we're looking for. Is there a number being added or subtracted on the end? If there is, it's non-proportional. So if this is proportional, what is my k equal to here? 1. It's just the number in front, right? Go ahead, off to the side, we're going to write invisible 1 so we don't forget. I'll let you guys catch up to that. Are you feeling okay so far? I know we're tired. I know it's Thursday. We'll get through it. Let's do something gross. What? Fine, let's do something ugly. Here's an ugly equation. What about this equation makes it so ugly? Who can tell me why is this so ugly? Muhammad, why is this ugly? It's backwards. All the terms are flipped around. This is not what I'm used to seeing. I'm used to seeing y go in the front, not in the back. Okay, I'm used to my x going before my b, not after. But it doesn't really matter what the order is, okay? What matters is, are we adding a number to our x? Are we adding a number to my x here? Yeah, it's just in the front. I could easily rewrite this, and let's do that. Let's rewrite this as y equals 4x plus 4. All we did was flip it, right? It was backwards. We made it frontwards, or forwards. Now, I've got y equals kx. Is there a plus b on the end here?
No.
Take another look.
Yes.
Yes, it's right there. Okay? It's a number being added on the end. There's my b. So would this be proportional or non-proportional? What do you think? Non-proportional. Good, we're getting it. This is non-proportional. So there is no k. Let's try another one. It's another tricky one. Take a look at that. Ask yourself, is there a number being added or subtracted from my x? Is there a number in front of my x? Just think about it for a second. Show of thumbs. What do you guys think? Thumbs up proportional, thumbs down non-proportional. What is this one?
Thumbs up.
Good. I see all thumbs up. Some sideways, maybe you don't know. This should be thumbs up. This is definitely going to be proportional. Okay? Is there a number in front of my x? Yeah, what is it, Jazza? It's a negative 1. So what is my k equal to? Negative 1. Is there a number being added or subtracted to my x off to the side? No. So that makes this proportional. Let's do one more. This will be our last one, and then we'll get to work. What do you guys think here? Thumbs up, thumbs down? Should be thumbs down, absolutely. Right? Why is this non-proportional? There's a number being added on the end. All right? If you see a plus sign at all, it's non-proportional. If you see a minus sign, you got to be careful. If it's in front of the x, right, like it's attached to the x, then that's not my initial value. But if it's off on the end, like we saw in the second example, then it would be non-proportional, okay?
No.
So there's no value for k. That's right, Mace. Feeling okay with that? Maybe? Yeah? Let's get some practice. We've got plenty of time for you to get done with it. And maybe finish some assignments you're still working on in Alex.